Today, later you should know uh, my teaching speed is getting faster at the second half. Um, so my teaching speed will be faster in the rest of the time. In the rest of time. In the beginning, I always get slow, trying to bring everybody on the same page. Try to bring, give a foundation, but we have 5 weeks, actually 4.5 weeks. So we'll speed up. We'll speed up. Um, so confidence interval. Today we're talking about. Last Wednesday we talked about the proportion. Two scenarios. Two scenarios. One is a proportion. Yes or no? Proportion. Is a yes or no situation. Yes or no situation. I wish you did the homework I gave out yesterday. Because, good. Because that will enhance. Alex. Um, not just sorry. Just sorry. I wait until to repeat myself. And there's the number. Let's go to the page. Page 466. 466. Page 400. 466. So the confidence interval for first scenario, for this scenario, is you get one sample, p hat, plus minus, um, the later part, the part after plus minus is called margin of error. Margin of error. The later part, this is called margin of error. Is this part? I copy down for students who cannot see that. That's the z number times the standard deviation. Z number times the standard deviation. And some did the homework, some may not do it. So let's look at one question in the homework. Page do it 21.7 right now. If you have not done it, if you have done it, that's even better. I'll give you 5 minutes. Do it now. If you have not done it, the question 21.7. Gun safety. On page 472. Do it now. So instead of I just repeat, you work on one question. And 21.9 is related. 21.9, question 21.9 is related. For online students, can you do it? 21.7, 21.9. The answer is provided on the back of the book. But do you know how to get the answer? want to say, do you own a drum? Do you own a drum in the house? Or do you support whether the store? Yeah, do you support owning a drum? Make it safer. So this is the yes or no scenario. It is yes or no scenario. Okay. Today we will get to hear. Um, and they randomly selected 1,010 people, and 425 say, I think so. I think owning a dog make it safer. So the purpose they are doing this is that they try to find out the whole country. They try to find out the whole country supporting the dog, but they cannot ask everybody in the country. It's just too many. So they asked a sample, 1,010, and 425 said yes. So they asked 110, 12. 425 said yes. Okay? What's the symbol here? What's the symbol here? What's the symbol here? Is this? Is this? Is this? Then it's a hat. Okay? The hat means it's a sample. This means the whole country, means the whole population. In this question, the whole population means every American. They do not worry about Chinese. They do not worry about your tribe. They're worried about American. So this is the proportion in American people. The proportion of American people supporting the God. This is the proportion of the sample. Proportion of the sample, okay? And what's the number here? You tell me. 42. Yeah. 42%. Yes, looks right. You get 69. I don't know where the 69 come from. Then find the margin of error. We need this. We need this. Margin of error. We need the margin of error, the plus minus. Frank, you should be. And first of all, we get the standard deviation. Is this part? Is this part? Okay. You have the p hat over there. So this part, the n is the sample size. The sample size, which is 1,012. You get this? You get it correct? Okay, good. Good. And for the z, this z is for 95, for 95% confidence interval, I borrow p hat. This p hat is in the middle. We want 95% confidence interval. This plus, this minus, and we want to chop the big part, 95% confidence. So we need the z. The z is 2. Okay. Is 2. So you use a 2, and here everything you have it, and you calculate it. So this is equal to 2 times 0.42 times 1 minus 0.42 divided by 1012. I should make this red. So is more or less, you could get a very long decision. You can get, but the board, I checked the board. I did preparation, okay? And at the end is 0.03. 0.03. You could get a long decision, but I guess by the book. So the interval, the confidence interval is what? I'm sorry, we wrote into is 42% plus minus 3%. 0.03 is 3%. Okay? Which means here is 42%. Here is 42%, or could be right in 0.42, and plus 3%, or minus 3%, and so plus 3%, that's 45%, and 39%. So from 39, you can write in plus minus, or you can write from 39% to 45%. This is the interval. Which is what's the meaning of the answer? What's the meaning of the answer? It means this P, 95% of time, 95% confidence is in this range. The national proportion in this range, 95% of confidence. We are not 100% confident. We are not 100% confident. we are 95% confident. Okay. Sometimes we want to say, can we be 99% confident? Can we be 99.7% confident? If I want 99.7 confident, then what's the answer? What's the answer? This one should change. Margin of error should change. This one should change. The minus and the plus, these should change. I'm modifying the question. I want 99.7. How to do it? How to do it? This Z value is 3. Okay? So this will be bigger. This will be bigger. I don't know. So it's 1.5. 1.5. So looks like it will be 45. Will be 0.045. 0.045. I'm sure this is correct. So here will be not 3%, will be 4.5%. Will be 4.5%. So will be 4.5%. I don't want to mess up too much, okay? So this is a 42% plus 4.5%. What's here? What's here? What's here? 46.5%. Okay? 46.5%. 42% plus 4.5%. Okay, now here 42% minus 4.5%. What's the number here? What's the number? 37.5%. So it is wider now. The national proportion 99.7% time. We are almost 100% confident. Is 99.7%. Is in this range, 37.5 to 46.5. Are you following? Is wider than 95. 39 to 45 is a 95% confident. 95% confident. And the wider is a 99.7 confident. Are you following? Um, these for these rules, I have to write it in every class. Right? What's the rule? 68, 95, 99.7 rules. Okay. For 95%, that's a 2. We need a 2 times the standard deviation. 2 times the standard deviation. For this, we need a 3 times the standard deviation. Z is a 3, and the standard deviation. But in real life, sometimes people, your boss, say, I don't want this much. This is too less. This is too much. I want a 98% confidence. I want a 98% confidence. You say, oh, my teacher told me for 95% confident, we use 2. For 99.7 confidence, we use 3. And your boss say, no, I want 98% confidence. And so they generate a table for this, which is on our book. Which page? Huh? There's a here. These are called a critical value. I'm sorry. These are called a critical value. You can see this, right? Online students, I'm sorry, the glare, they cannot see it. And it's strange, they don't so for 70% confidence, you see, is 1.04. They don't list it 68%. This table, the student generated this table is a little bit strange. They should list it 68% in between, and this is 1.0. They listed as only 70%, so it's slightly more than 1. For 70, it's slightly more than 1. Only this one, 95%, we keep saying 2. But the real value is 1.96. The real value is 1.96. This is correct. This is correct. And for like here, the book uses the 2 because it matches the answer on the back. So they choose 2. Sometimes we use 1.96. Sometimes we use 2. Depending on you want to show off or not. So,
1.96.
actually it's 1.96. If you round up, then that's 2. And strange, they don't list the 99.7. This is a very famous rule. This is a very famous rule. They don't list it. So they listed 99.9%, which is more than 3. Which is more than 3. If they listed 99.7 here, should be what? Should be 3. Oh, the 98. So if your boss wants to be 90% confidence in this question, your boss wants the 90% confidence, then you should, which value you should use? Which value, the critical value Z, 1.64. 1.64. Yeah, you don't need to calculate. So this is just a 1, 2, 3. A very easy, very good for teacher to give out the homework, because you can use 1 or 2 or 3. And but in real life, your boss may not want this, the 95%. This is very common. This is very, very common. Most common. But some homework you will have, they want 90% confidence. They want 90% confidence. And you have to check. You have to check the table and use 1.64. Instead of 2, instead of 3, you use 1.64. If they want 80% confidence, then you use 1.28. Are you following? And just 1 minute. Just 1 minute. This is the Z table I give out in the WeChat group. Okay. This is also here. This is also here. I would just want to show you. First of all, let's review the a little bit. 68% confidence. Let me erase this. This is we said for 68%, is the 1 times standard deviation. Right? So look at the 1.0. 1.0 is what? 0.34. Do you see it? Which means this part is a 34%. Do you see? And including this part double, that is 68%. Do you see? And for 95%, I said sometimes we use 2, sometimes we use 1.96. Okay? Sometimes we use 1.96. And look at 1.96. 1.96 is here. I mark it with red. 1.96 is 4750. Which means this part is what? This part is 4750. Do you see it? 1.96. You double including this part is 95%. Okay. And I said for the 99.7% is 3 sigma. 3 sigma, right? It's very wider right here. 3 sigma. Okay. Then let's check. 300 is 4987. Here is too messy. I use this side. Okay, I'll redraw another one. I'll redraw another one. Now is 3 sigma. Okay. According to the table, how much is this area? 30 4987. 4987. 4987. You double it. Is 99.7. And this board says say 90% confidence is 1.64. Let me find my picture. Where is my picture? Remember 1.64. Where is 1.64? 1.6. I need a heading. 1.6. 4495. Do you see it? 4495 is 4495. You double it, it becomes almost 90. Or you double it, when you is 0.09. Huh? Is 89, 899. Is this the number? 0.899 is we call it 90%. Okay, and this is the Z score is 1.64. This is a Y for 90% confidence. For 90% confidence. For 90% confidence, this is a 1.64. This is 1.64. So, the bottom line is for different confidence level, the easiest one is the Z is 1, Z is 2, Z is 3. But if your boss wants something else, if your boss wants, is that here? If it's not here, you can check. Half of your boss wants confidence. Let's say he wants 80% confidence. Let's say he wants 80% confidence. Then what is the Z value? This part means is a 40%. This part means 40%. So the total is 80. Okay? This part is 40%. Put in another way is a 0.40. Putting another way is a 0.40. Okay? Putting another way is a 0.40. Then, where is 0.40? Where is the 0.4? This is a 0.4015. This is a 0.4032. So, by looking at it here, is a 1.2. Is a 1.2 and 9. So here is a 1.29. According to the table, okay? Because here is a 0.4015, is a close enough. So, is this row 1.29? Let's check our book. 1.28. Right? Is you know, the curve is not always has a run up, always has a rounding. Okay? So you know how to use you know how to get this number now. Okay? Okay, we take a break. Oh my goodness.